why Clojure sucks and why you love it anyway. I'm not afraid to admit that probably for the first time in quite a while, I'm nervous giving a talk. I think rightly. I'm giving a Clojure sucks talk at a Clojure conference. But there are mitigating factors. That's the point. That's the point. So I've been using Clojure for a long time. I think I'm, if I can count right, I'm into my 5th year of using Clojure seriously, into the 4th year roughly of using it in production environments and things like that. So along that path, I learned a lot about Clojure, obviously, about the things to avoid, the things to really recommend it, but in particular, writing the book with my great co-authors, Brian Carper and Christoph Grand. It really forced me to crystallize what about the language was excellent and what about it you needed to avoid, mitigate, or otherwise just deal with in order to do the work that you need to do. Because we needed to communicate to people who had never touched Clojure ever, and communicate using not the most ideal medium, perhaps. So between that and hanging out in IRC for way too much time, I thought this would be a good time to sort of present a high-level discussion about what the things are in Clojure that are a little difficult, a little warty, things you might want to avoid, and how to work around those things. So what I'd like to do is do that. I put holistic here. That's not right. Really, it's a grab bag of things that I think are worth talking about from a pragmatic user's perspective. Of course, if you're using Clojure for just hobbyist stuff or you're doing research with it, then some of these may not apply to you. But I've always been using it in a commercial setting, and so that's where a lot of my experience and my bias comes from. And really what I want to do is answer the question that you may have. If you've just started using Clojure, you're considering using Clojure, what will you wish you had known now, a year from now, or 18 months, or 24 months? I don't think there's going to be anything groundbreaking here, but just some things to think about. And honestly, my main objective is to get out of the building alive. I'm surprised Rich isn't right there with a bunch of tomatoes stacked in front of him. But seriously, I worried about the premise after I submitted the talk and it was accepted, and I really needed to do more than just have notes and things like that. Because it's really easy to write a flaming blog post, right? You can say X sucks, Clojure sucks, Scala sucks, the JVM sucks, and throw it out on the internet, and the next day is like the last. But I think it's harder and hopefully more rewarding to try and have a rational discussion about the shortcomings of something that we all enjoy, that some of us love, that some of us have built our livelihoods around, so that maybe we can have some productive motion towards addressing those or building practices that everyone is aware of and can communicate effectively to new people that they're bringing into the fold, so that we can address the things that bug us the most and improve the environment for everybody. And I was reminded while I was putting these slides together of the monologue at the end of Ratatouille by the food critic, who talks about the risks of being a commentator and the damaging effects that sort of reflex criticism can have within a world where you want to encourage the things that are new and innovative. Just throwing out how something is unusable, it didn't work in my circumstance, so it sucks. That's not adding much to the world. And for the things that are innovative and new, like Clojure, it needs friends, and it needs friends that aren't irrational, that aren't blind evangelists to the thing that they think is the best. And there was a recent blog post about how your favorite programming language is not enough. And the real point of that is that you don't want to be partisan. You want to have a balanced approach to things and look at what can Clojure learn from other languages, just as much as what could you learn from Clojure. So, I'm going to measure the success of this talk by how many times people giggle about the topics that I put up. Yeah, namespaces are tough. Namespaces are tough in general, right? I mean, Clojure namespaces are really good compared to nearly any other language. I can't think of one that I would rather. I can't think of a namespacing system or a modularity system that I would rather have over Clojure's. However, this large batch of complexity, what does required do, what does use do, what does referred do, how do they interact, what should you use, what are the traps that are waiting for you when you blindly refer namespaces all over the place, the whole notion of var immigration and things like that. There's a lot of complexity here, and I think it's no one's fault. None of this is anybody's fault. This was a great experiment that was put together, one of the oldest things in the language outside of like the core compiler and core library and things like that. And it's served us very well and will continue to serve us very well. But there's a lot of complexity here, and people trip on it every single time. I still trip on it in terms of what should the best combination of require and use be. Maybe you should always use with a empty only list and use an alias, so then you can add in things that you want to use in blindly easily and things like that. And then there's this whole, do you need to quote your lib specs or not? In what context do you, right, you need to use the colon in the NS form, although not really anymore, because anyway, it's complicated. It shouldn't need to be like this, right? One really concrete problem, especially for those of us that do a lot of interop, is that there is no package wildcard import. And I do maybe more interop than most, maybe less, I don't know. But I know that when I'm working with a library and I need to touch 25, 40 classes within that Java library, which has happened, you have an entire screen filled up with your import clause, because you need to enumerate every class. And there's ways to do this, and there's utilities that will automate that out, but it's not part of the base functionality of import, and so very few people do use it. I'll take questions later. Then this is a little more subtle. So when you resolve the value of a var, here this value G in some namespace, you get the value of it. You don't get the var. And we were actually just talking about, myself and a couple other people were talking about this last night. The one on the left, you get the value of G, say it's a function. On the right, you get the var containing that value, that function G. It's essentially equivalent if you are simply loading into an application and running stuff. However, when you're in a development environment and you want to connect using a REPL and modify code at runtime and do all those interactive development things that make Clojure extraordinarily productive if you know how to use those tools, and you use the form on the right in exactly the right spots, then if you reload the code that defines G or some code in some namespace 5 levels down in its transitive dependencies, then you'll see that result immediately. Whereas if you use the form on the left, you won't. And that's a 2-character change, and it's a very subtle tripping point for people that don't understand the correspondence between, or that don't understand how vars and resolution work and the implication of that with regard to interactive development. And this one gets me all the time. So if you have a type that you define in some namespace, and types and records and protocols boil down to host classes and interfaces, you can't just import it, right? Foo needs to have been loaded here in order for the type, a type, to be imported. And I I do that on a weekly basis where I hit import, some namespace, or in this case package, and type, and it fails. What's going on 5 minutes later? Oh, right, I don't have a require for that. And so that's something I hit every single time. It's a point of repetition that shouldn't need to exist. And I'm going to go through these last couple relatively quickly. In larger applications, you often have a bunch of utility functions that are coming from internal libraries that you're using, and you use them everywhere, and you want to be able to have them available everywhere. And often you need to just copy and paste. Here's my namespace declaration, copy and paste, twiddle a couple of things, as opposed to saying, my new namespace A should be like my old namespace B with these modifications. And again, there's alternative implementations of the namespace modification functions like ns and require and things like that that provide this, but you need to be aware of them and use them if you want to. And this is a personal gripe of mine. If you load a namespace and some transitive dependency fails to load, you've got a typo somewhere, now you have a Clojure environment with half-loaded namespaces all over the place. And that's always bothered me from an introspective and introspection and tools perspective, because now you have vars listed in like outline browsers and things like that that haven't been loaded properly or don't have their dependencies available properly. And so I've always wanted code loading to be transactional. And obviously there's side-effecting things, especially when you're loading configuration files from disk in a top-level form, or you're initializing Java classes and things like that. But I've always wanted namespaces to be transactional insofar as when you perform or require or use, those vars that go into the namespace are either there or they're not in their full form or not. And I know there's bootstrapping issues around that, but it's something that's always irked me. So that code doesn't work, right? And it doesn't work because Clojure doesn't support any notion of forward references. In this case, prior to main, you would need to have a form that says declare helper in order for the compiler to resolve the interned helper var. And this is unfortunate because it's one of the few places where Clojure forces the programmer to babysit the compiler. When you are writing a library that you want to be amenable to someone understanding it later on, whether it's a teammate or you 6 months later, personally, I've always liked to have the highest level functionality be at the top of the file, because when you open up your buffer, there's your entry point. Maybe it's an API with 10 functions. You want to see what the shape of the API is, not this however many lines of helper functions and implementation details that you often need to wade through, that people leave at the top of the file so they don't have to use declare in order to get the vars in turn first. And all this drives out of what, for a lot of people, is Clojure's unintuitive compilation unit. So most other languages, the compilation unit is the file or the class or something like that. Whereas in Clojure, it's each top-level form is a compilation unit. Dynamic scope and I have a long history, and not a very positive one overall, I think. It's a very common pattern, especially in, say, database libraries. So JDBC, CouchDB, MongoDB database libraries, they all have this pattern where there's a function or a dynamic var that you need to bind with some configuration. So, with foo is with database or with Mongo or whatever it happens to be. And then you can perform your database operations within the scope of that binding form without repeating that configuration over and over and over. And that's great. I'm all for concision. I don't like verbosity. But dynamic vars, dynamic scope comes with a price in that fundamentally every dynamic var ends up being an implicit argument to every function that you happen to be working with. And you really see this when you look at documentation. Like if you look at the code completion pop-ups in Slime or in counterclockwise, you're going to see the arguments to the function, right? This function takes ABC. It's not going to have an entry saying, oh, by the way, you need to go bind this var in order for this function to work. And it gets even worse than that when the top level of an API isn't the thing that touches the dynamic var. Maybe it's another var 3 levels down in another library, and you need to make sure that you've called whatever appropriate setup function needs to happen in order to set up that scope. And this is mutable state, right? And we all know what mutable state is. It creates complexity. It makes it very difficult to understand what's going on within a library. It makes it more difficult to test functions. So in this case, if you wanted to test function f, you got to make sure that you're setting up your appropriate dynamic scope in order to make that test work out properly. And so I've found that, especially in the past year or so, I just stopped working with dynamic scope. I stopped writing code that requires it, and things get simpler. Maybe you pay a slight price in a bit more verbosity, but I think it ends up being worthwhile in terms of having a clear mental model all the time, where you just look at the documentation, here's the arguments this function takes, and I don't have to worry about anything else. That really goes to being able to focus at the problem at hand as opposed to understanding implementation details. So binding conveyance is this thing where prior to 1.3, if you set up some dynamic scope and then started a future or sent an action off to an agent, that dynamic scope goes away within the context of the evaluation of that function, which was very disconcerting. Is very disconcerting. You're within you're writing this function that's going to go start a future or send something off to an agent. You have a particular notion in your head of what your state is that you're working with, and you send that action off. You feel like you shouldn't have to think about the fact that this state's coming from a thread local dynamic var versus this state that happens to be a local argument, right? And I was one of the people that was wailing away at Rich saying, this is unpleasant. You have to set up a new scope with an anonymous function and bind things out to use the same values as in your current dynamic scope for your future or your agent action or whatever. And so binding conveyance went in, which means that your dynamic scope, when you send off an agent or send an agent action or start a future, et cetera, your dynamic scope will go along with you. And I think that's a win overall, but it ends up causing some problems when you don't want to have your dynamic scope go along with you. The whole notion of dynamic scope and Clojure's fundamental concurrency operations has been complected in this way. So I think it's great for the common case, but when you start working with circumstances where you don't want to have your dynamic scope carried along with you, binding conveyance can be problematic. And so overall, I think dynamic scope is sort of kind of considered harmful. I don't think there's a lot of reasons to use it, a lot of reasons to recommend it in general practice. There are a couple of good scenarios where you need to use it. For example, auxiliary returns. So if you have say an HTTP library with a function that you want to return the content of a GET, if you need to also get back the status code or headers or something like that, but you don't want to always have to deal with a response map in the happy case, for example, then you can set up a binding that clients can opt into. You can set up a dynamic var that clients can opt into binding, and then your library can set bang your headers or your response code, which the client can then check when it wants to. And that's breaking things out nicely in a way that doesn't make the var an argument. It's flowing in the other direction, and it's opt-in. Software transactional memory is one of the marquee features of Clojure. It is often cited as one of its most distinguishing characteristics. Certainly when it came around some years ago and was the only widely available and easy to use software transactional memory system, it was and still is groundbreaking. But using it effectively, I believe, is hard. And it's hard, especially insofar as it looks easy. So tutorials and websites and books, including my own, have examples about how to use software transactional memory. And because of the nature of examples and tutorials, they use simple data models and simple operations in order to exhibit the characteristics of the system. And you start to get a sense of, oh, this works well. You know, you have these 6 refs and a bunch of operations, and here's some data coming in, and you toss a bunch of threads in the air, and things work out. And you start to get the sense that, well, this is a little bit of fairy dust that you can sprinkle over your state, and things will just work out well. But it's not actually that cut and dry. I mean, the STM is essentially an in-memory database that has superior Clojure integration. And when you think of it that way, then you realize that there's implementation details and semantics that go along with the STM that don't quite bubble up into the clean API and operations that you look at syntactically. A couple examples of this. One is ref granularity. So Christophe wrote a great blog post about a month ago, I think, called The World in a Ref, where he talked about how it's difficult to determine for a given data model what the right ref granularity is. So I mean, STM looks simple and easy and straightforward if you're using refs containing scalars, right? But if your data model is a complicated set of maps, or a single map that represents your entire world that has 150 keys and composite data structures as values, where do you put the ref? If you wrap the entire world in a ref, then you're going to have serious contention going into that for something that needs to tweak one value down here in a leaf. On the other hand, if you have refs throughout your data structure, then you have a serious problem in terms of, then you just defeated one of the greatest advantages of STM in that you can snapshot your in-transaction value easily. You can't just deref it. You have to deref it and then walk through your map, for example, unrolling all of the refs so that you finally have a immutable data structure that no one else might have a reference to and be changing something out from underneath you. And finding that right granularity is not easy. I don't think there's any known, well-known way of figuring that out. It's trial and error, it's testing, it's load testing, it's dependent upon your operations and your data model and the kinds of traffic or load that you might have. So I think this is, STM is great, but there are significant changes that come in with the data model. And one of them is that transactions are non-deterministic. There's no guarantees of this transaction will succeed. If you have high load, if you have long-running transactions, if you have a heterogeneous mix, then it's very difficult to say that this transaction will succeed, whereas this one will fail. And that can end up producing a lot of very strange results and unfortunate failure conditions when you're in a production environment and you have a spike of load, but you never tested up that high, or you never tested with this mix of operations. So I think there's, STM is a new field overall, not just in Clojure, obviously. And I think more work in this area so that we can develop some good guidelines about how to structure our refs with regard to granularity, as well as maybe have some guarantees around, I always want this transaction to succeed. This has higher priority over this one, et cetera, et cetera. I think that would be beneficial. Overall, I think STM is overused. Because it is a marquee feature of Clojure, people jump straight to it. They think, oh, software transactional memory, I'll do this, when honestly 2 atoms would be fine because there's no coordination going on between the threads of execution. Right. Oh, and then most applications that we write, or that I write, use an external database. They delegate out to a database like a relational database or CouchDB for consistency and coordination. And delegating out in that way is a good thing, and it's a good pattern, and we know how to do that pretty well. And a lot of times it makes things a lot simpler, especially when, like, the fundamental design strategy of a lot of distributed application architectures is to minimize the amount of state held in, for example, compute nodes. You want to be able to have a node that if it goes down or if Amazon has a network outage, which hardly ever happens, then you will be able to bring up another node and not care what was on that first one. Whereas if you're using STM or other ways of managing state within your compute nodes, for example, then you will end up engaging in an anti-pattern of retaining state and coordinating state in things that really should and could be stateless. So I used Python for a long time, or not a long time. 2 or 3 years I used Python extensively, mostly for web stuff. And I never read a single line of Python source ever. That's not the case for Java. I mean, I have the Java sources open constantly for all sorts of reasons. So I don't think there's any, it's not like Clojure is alone in this fact that you really need to, at a certain point, it's going to happen. You don't know what's going on. You don't understand what the semantics are of this. You just end up needing to read source. You need to open up core.clj or the reader or locking transaction or see how agents are actually interacting with thread pools or whatever. And a couple of examples off the top of my head. Nobody understands how chunk seeks work. Fundamentally, out in the world, aside from crazy people like me that have read every single line of how chunk seeks operate, nobody understands how they work. And so you need to go read that. And same thing with all the inline stuff. And then, core itself has like 600 public vars of fantastic functionality, but literally one person knows all of them, right? There's a lot of great stuff in there, and you should go and read core.clj because you're probably rewriting half of the functions in there on a regular basis. And that sort of points to something I'll talk about a little bit later about documentation and what we should be aiming for in order to make Clojure a discoverable, easier to use language, also with regard to libraries. So the JVM is the thing everybody loves to hate. And it's understandable. I mean, especially given the rap that it got over the late 90s and early 2000s and things like that. There was a blog post not too long ago that put pictures to that long-running joke about what programming languages would be if they were cars. And so, the JVM is a sturdy but boring and slightly clunky F-150, and Lisp is a DeLorean. It still has the it has the gull wing doors, which no other language still has. It still has, the parentheses and all that. And then the effect is this. And it's not wrong, right? It's not wrong. This isn't that's a very accurate representation of what's going on. We all know it doesn't start up very quickly, especially people coming from Ruby and Python and other, quick interpreters or, people that are used to compiling to C or whatever. And that's getting better. I've seen startup times, especially under JDK 7, loading Clojure core under 2 seconds and having a REPL ready. So it's getting better, and it will continue to get better. But that's sort of minor. What I think you really should focus on is that the JVM, as it's often cited, does have a lot of fantastic libraries. The flip side of that, it has a lot of libraries. And a lot of them are not fantastic. And especially when you are using libraries as a means to an end. Within Clojure, we often wrap them, even internally. Even if you're not going to put something on GitHub that depends on a particular Java library, you're going to wrap it so that you have a fluent, nice to read, easy to use API for something that happens to live in a JVM library. And it really helps to develop a refined palette for spotting those Java libraries where that is amenable, where that's easy to do, and where there's nice correspondences and where there's no conflict. So if you look at the Java doc for a Java API, you do it enough, you'll begin to see, oh, this isn't going to work out with persistent data structures. I see all these side-effecting things, and functions returning void everywhere, and you run in the other direction as fast as possible. And then you see other things like libraries that have totally unacceptable data models. Like everything needs to be a subclass of an abstract class. And so you're going to be stuck working with proxy and gen class, and you're going to take a penalty hit, and your build process is going to be implicated in the whole effort, and it's just not worth it usually. So you want to develop that refined palette because there are fantastic libraries, gems, that are world-beating. There's nothing better except what's on the JVM in certain areas. But in other areas, you need to tread lightly. And of course, you could go on with issues with the JVM, but that's relatively well known. The saving graces of it is that it's damn fast, it's reliable as hell, and it's easy to get your applications once they're built out into the world, because everybody can run a Java app one way or the other. You can deploy it to however many platforms up in the cloud, et cetera, et cetera. One of the key issues with Clojure being a JVM language is this requirement, or this desire among a lot of people to get Java class files. And Clojure supports this, supports it pretty well through a process called ahead-of-time compilation, and basically don't ever use it. That's the top line message. It bloats the artifacts, but that's not even the significant problem. Part of the bloat really is that the compilation is transitive through all of your dependencies. So if you need one def type AOT compiled because you have a customer that's using JRuby and you don't want to have to force them to go through Clojure lang RT in order to twiddle your Clojure functions, you're going to end up compiling Clojure set, for crying out loud, down to Java class files in order to get that one class file out. And it's to the point where tools like Lineagen have options to go and back into the set of AOT compiled class files and delete out the ones that aren't related to the project that you're actually working on. So this is an issue, and it's an open issue, and hopefully will be addressed sooner rather than later. But the real problem is that AOT compilation introduces compatibility risk for anything that you compile. So if you compile something, if you AOT compile something against Clojure 1.3, it may or may not work against Clojure 1.4, or 1.2, or 1.5, even if the functions that it touches and their arguments haven't changed because of implementation details that change within Clojure's implementation. If you absolutely have to deliver class files, only ever do it as the last thing that you do before giving it over to your customer or to your client. Certainly never, ever put AOT compiled class files in a jar up into something like Clojures or other Maven repositories, because other people will trip on that compatibility issue down the road when they've been using your library that's AOT compiled, that probably has a copy of Clojure contrib in it because of the transitive compilation, and they're going to trip on the next version of Clojure when it comes around. So I'm going to have to speed up a little bit, but parentheses, we have come to love them. Other people hate them. Whether we love them or not, maybe that's a Stockholm syndrome kind of thing. The nice thing about parentheses and the other literals that are provided for in Clojure is that it means that Clojure is a homoiconic language, and that gives you macros. But as we've heard from tons of people, including myself and Christophe and Michael Fogus and others, macros are difficult to get right. They don't compose with other constructs within Clojure the way functions do, for example, and they're really rarely what you want when you're building libraries and applications. My view is that macros are too easy. Someone reads about macros, again, one of the main marquee features of Clojure, that you can do this advanced compile time metaprogramming and do what you like. And people start writing macros upon macros, and then they write a macro, and they need to write everything else as a macro in order for that macro. It ends up being a disaster in a lot of scenarios and leaves a bad taste in a lot of people's mouths. And I'm reminded of something that a lot of people say that aren't Lispers, but do like macro systems, or compile time metaprogramming, I should say, that you don't need to write in ASTs in order to modify them. And there's lots of instance proofs of this, right? That Groovy and Haskell and Scala coming up soon apparently are building these compile time metaprogramming systems, and they are not homo-iconic. And I'm not sure if maybe that's a better balance, where the people that really need to have macros, presumably with a higher level of expertise, they need to put in a little extra work in order to get to that point. I'm of two minds about that. And I'll only say that there are a lot of things that show that homo-iconicity doesn't simplify a lot of aspects of metaprogramming. And so there's this compiler API that you need to know in order to write truly effective Clojure macros, especially if they're going to be interacting with other parts of your code. So when you have a great hammer, of course, everything is a nail. And a lot of people like to try to use Clojure everywhere, for every purpose. And I fell victim to this way early on. I remember late in 2008, I wrote a tagged binary reader, right, so that I could take Clojure data structures and serialize them out very fast. It was faster than Java serialization, certainly way faster than the reader. And this impulse, I think, is wrong in a variety of ways, because S expressions aren't always superior, right? You have what Clojure provides you in terms of the data model you can work with. What if you want to work outside of that data model? And we have some motion towards that with the tagged reader literals. But one thing that it's always going to come down to, and a big issue for me, is that there's no way to have binary data within readable code. Also, the reader is slow. Let's be honest about it. If you're going to be using it as a generalized serialization and persistence mechanism, you're probably going to be very disappointed if you were used to nearly any other persistence mechanism. And if you are working with other people that are used to taking in and producing JSON or XML, then S expressions generally aren't going to cut it. Lisp has been called a big ball of mud. And this is either an insult or a compliment, depending on how you look at it, right? So this is an example from the book, looking at what you could do with composition of functions using partial and all that. And you can produce far more complicated constructs than this, of course. But you can dig yourself into a hole pretty easily, especially if you get too lofty or loose in the composition of all these generalized pieces of functionality. Insofar as if one part in your pipeline here produces a return value that doesn't produce an error until 3 levels down, that's going to be a little difficult to debug. And the same thing applies to chaining together large sets or a large number of transformations over lazy sequences. So I don't think it's actually a ball of mud. It's more like getting caught up in a pile of yarn, especially when you start looking at the stack traces that often come out when you've been composing a lot of functions together. It's very hard to find out where the real issue is. I should have made that bigger. So, lots of languages have different learning curves, and Clojure has its own. I wouldn't want to try to produce one that represents it. I prefer the crossing the chasm metaphor from Gordon Moore. And there's a lot of things that someone coming into Clojure needs to understand. There's a lot of different hurdles that you need to leap in order to become productive and have a happy outcome of using Clojure. And it's all of the ones that you can expect, right? And I'm not sure what the solution is, because for a lot of these, you know, this goes back to the documentation, right? All of us, no matter how long we've worked with Clojure, no matter how experienced we are, we're always going to be tripping over, what does that function do again? What does the new function do? What does the function in this other library do? How do you discover and learn how to effectively apply Clojure libraries, including core, and what are the mediums and resources that you need to do that effectively? I think that's an open question. There's a lot of tools that are working on doing this. There's Clojure Docs. I did one called Clojure Atlas. There's all sorts of other things that are sort of in the air as people trying to figure out what's the best way to smooth this path. You know, tooling and all that stuff is not the purview of the language itself, but obviously it's implicated in whether you are successful or not. The language could be the best thing in the world, but if your preferred environment doesn't have an easy to set up, easy to use, easy to maintain, and long-lived support for Clojure, then things are going to be difficult for you. And ironically, this last one is probably the easiest, just because we are deploying on the JVM. Again, it's one of its big advantages is distribution. And you know, there are other hurdles, but I think a lot of these are meta in that they aren't strictly about the language, but they are about what gets built around the language and how we can make what's around the language be better than what it is today. So I think in the description for this talk, I said I would move through technical, social, and existential issues. And so there's this. And not being morbid in any way, and I don't want to do that, but Clojure's bus factor continues to be 1, or something approximating 1. And I think we can all agree, given the history of different languages that have come up and faded away or are still with us for various reasons, that a singular vision is the only way that a language can be developed and can thrive. Languages and systems and tools that are built by committees often are the least pleasant to use. And so it had to be 1 at some point, but it continues to be 1. And from the perspective of someone, again, going back to, you know, if you're a business-oriented user of Clojure, you're building your livelihood off of it, that can be a little concerning. And, you know, we can look back at what happened with other people that decided to do other things with their life, which is perfectly reasonable. But the difference between Clojure and, you know, dive into HTML or Python or the cumulative works of Why the Lucky Stiff is that they were great things in the world that contributed a great deal, but no one built a livelihood on top of it, or a business on top of it, or a community on top of it. And something that really made me think about this in depth was I think it was a couple months ago, when it really became evident that it was a good thing that the Apache CouchDB project's bus factor was not 1, because its original creator, Damien Katz, who, again, he moved on to other things, but what he moved on to was a company called Couchbase, which originally was using CouchDB, but then made a technical decision and decided to start promoting something that wasn't totally not CouchDB, unrelated to CouchDB, essentially, incompatible. And if CouchDB's bus factor had been 1, then the project would have been finished, right? Or effectively finished. On the other hand, because it wasn't, because it had been folded into the Apache process, whatever recommends or doesn't that process, it does ensure that a project has a number of committed committers and a number of people stepped into the void, and companies pledge support, and CouchDB looks more vibrant now after Damien Katz's departure than it did a year ago. And I think there's a good story to tell about Clojure's position in this circumstance. First of all, it's released under the EPL, and there's a phenomenal community around it. There's not just one or some small number, but I can think of probably a couple dozen people that I would trust to make another Clojure implementation or start from the base that exists that I would use personally. And so I think between the open source factor and the community that's surrounded it with phenomenal expertise and intellect, I think things are good there. More importantly than that is that the ideas in Clojure are far more important than any particular implementation. So we all use, roughly speaking, the JVM implementation of Clojure. But there are others, right? There's Clojure script, targeting JavaScript. There's Clojure CLR, which is really instructive because it's largely the product of one person, one extraordinarily dedicated and smart person, but it shows that there is less risk here than we might think. And then in just the past couple of weeks or month, there have been 2 other separate implementations of, in Clojure Pi's circumstance, Clojure running on Python, so you have the compiler available at runtime and the whole deal, and then Clojure Scheme, which I think is based on Clojure script, targeting Gambit, so that presumably we may be able to run Clojure script apps on the iPad and things like that, but compiled down to C and using Gambit. Anyway, the point of this is that the ideas are more important. And given a large enough community, which I think there exists, and given enough expertise, which I think exists, one's investment in Clojure is very safe from any existential threat, either people deciding to go off and do new things or worse. So, the final point I'll make is that the thing that most mitigates all of these risks, including the bus factor stuff and the documentation, the availability of libraries, is that we need to continue building a community of power and responsibility, of people that are engaged, building new things, willing to help make the things that are there better, and willing to take responsibility and take ownership of the things that they care about. And enabling everyone to do that, I think, is one of the that's the ordinal point of what we need to do in order to ensure that Clojure is healthy and long-lived. Thank you.